Okay, so yeah, so we have to find out the phase difference, and so it will be what?
So I understood.
Ah,
I understood this. It's the adjacent ones.
yeah.
Yeah. That will give you 180.
Ah,
Yeah, that's it. That was the only question. And yeah, I've sent others.
yeah. Yeah. I have. Okay. So see the so path difference. Let me complete it, and I will share it. So path differences.
Oh, right, you're recording this lecture, right?
Yeah, path differences 50 minus 25. That is how much? That is 50 only. Yeah, sorry, that is 25 centimeter. So phase difference delta phi will be 2 pi by lambda. Okay, into the path difference. So lambda we will take what? Between one peak and another peak we take. Okay, but since this is just half of it, okay, the original curve is like this. Okay, so it will be just double of this. Okay,
So with
uh,
50.
it will be 50. Okay? Lambda will be 50, and this path difference is 25. So ones are twos are two. So phase differences pi radians or 180 degrees. Okay. That's why it's coming like this. That's why it's coming like this. So let's move to some another question. I think this was your another question. Oh, this was the same question.
Oh yeah, yeah, you solved this one.
Okay. Now some question papers you have sent me, and there you had the doubts. So those we will discuss. I'm opening that. So this was the some paper October November 2020. So let's see where your doubt is. So 19th you have the structured question, structured paper test.
Yeah, it's structured paper too. So I'm done solving with the past papers
Okay.
from 2016 to 2022.
Okay. So here is your doubt now, I think this one. On figure
Yeah, I've
2,
circled it.
sketch a line to show variation of distance moved by the block with time t from t equal to 0 to t equal to zero point 0.2 seconds.
My, my
Numerical
doubt
values of
is,
distance are not required. Hmm.
yeah, doubt is this correct?
Distance moved versus the time. So what does the marking scheme says? They don't give the
They said curved graph.
curved graph.
Yeah,
Yeah. So what is that? Some block is there, some so
but then how will it be curved? Like, in what direction will it be curved? Will it be curved
a
down
small,
or from above?
let me check, and a small block is lifted vertically by a toy aircraft. Okay. So yeah. So we have this kind of a toy. Okay, hmm, there's a block that is hanging. Okay, so the weight will always act downwards. Okay, but it is going up because we have the rotor. So there will be some lift force which is there in the upward direction. Okay, there's some lift force is there. So the resultant force is upwards. Okay, there is some lift force acting. Okay, lift force is acting. That is why it moves up. Okay, so that force is greater than the weight of the object. That is why it is moving up. Okay, so what is given to you? As the block is moving upward, the string breaks at t equal to 0. Okay, the block initially continues to moving upwards and then falls and hits the ground at t equal to 0 seconds. Okay. The block initially continues to moving upwards and then falls and hits the ground at t equal to 0.9 seconds. Okay. The variation of the velocity of the block. So they are not talking about the aircraft. They are talking about the block. Okay. So when the string breaks, by that time, okay, the block has certain velocity, kinetic energy. Okay. So it will keep on moving little bit upwards till all the kinetic energy gets converted into the gravitational potential energy. Okay, and then what will happen? Then again after that it will fall down because of the gravity acceleration due to because of the attraction of the earth. It will fall down. Okay, if air resistance etc. is there, is it there? Air resistance? No. See, velocity versus time graph, it's a constant. Okay, so it is moving with the acceleration due to gravity. So see what is happening as the ball is coming down. Okay, its velocity is increasing, isn't it? As the ball is coming down, its velocity is increasing because there is acceleration is equal to what? Acceleration is equal to acceleration due to the gravity. Okay, so if the velocity increases, so does the distance. Okay, so it will, as it is coming down and down, what will happen? It will cover more distance in the same time. Okay, so what will happen? The distance versus time graph and this graph is not correct. Okay, so this graph will look something like this. I'm drawing
Wait,
another.
so the block is falling down. So the
uh,
block is falling down, and there is no resistive force.
oh, there is only acceleration due to gravity. So this graph is
Oh, wait, I'm so dumb. So it should go from down to above to up.
should be like this, and a graph should be like
Yeah.
this.
Oh, all right, all right. So I solved this
And also,
paper like,
also if you know that velocity is what, that is the dx by dt, yeah, or ds by
yeah,
dt.
velocity keeps increasing.
Velocity keeps increasing, so it will happen. So here, if
So
you
more distance covered.
take the gradient, and gradient, it will keep on increasing. So this is the correct graph. Okay.
Oh yeah. So I solved this paper like a month ago, so I was very dumb back then.
Okay. So is this clear, Alasha? Are you understanding?
Yes, I mean, I just joined, but yes.
Huh. So this is
Yes, I solved this one.
huh. So such questions you can expect in the exam.
So I always get that phase difference question and the graph question wrong for
Okay.
some silly mistake. No, sometimes I don't even understand it.
See similar types of questions, and you will get the idea. Okay. You try to search for that and the answers to those which I am not able to tell you. Okay, right now. Okay. See in the internet if
Yeah.
something is there. Maybe I'm missing something. Okay.
So I cannot find anything on the internet because no one solves our past papers. Everyone has like answers to 2018, 2019, 2020, 20.
So similar questions will be there, na? Similar to those questions. Phase difference, I
No,
think.
so they don't repeat. Cambridge does not repeat questions from 2016. Like they will repeat
They
questions from
don't
like
need to
very old
repeat, but
papers.
similar type of questions on phase difference, that is very common, na? Phase difference, path difference, very common in this as well.
Right.
So you can get some idea from there. So let me see if you have any another doubt in this question. This question paper. Okay, this was also the doubt.
Yes, so actually I do have a doubt. If we go up, I don't have doubt anywhere else. It's fine.
No, here you have written
We can
wrong.
go up.
4.2, this is wrong. No?
Oh, I understood my mistake there. I forgot to add MG.
Okay, so you understood your mistake.
Yeah, I did.
So let's check if in this paper you have any other question doubt. Okay, this question you have the doubt.
Oh wait, no, I understood the mistake here too.
Huh? You understood this?
I understood the mistake. I forgot to update it. So basically, the phase difference will be 180 because it's two adjacent antinodes. It's not one complete oscillation.
And
I
this
understood
question
the
also you
mistake.
have made mistake. This question,
I understood. I wrote the correct
this
way of
one you
solving it.
understood. This one
Yeah,
resistance.
yeah, I did. The same question, so can you go up? I think there is something I want to ask you. In the
Huh.
same question where I asked you a doubt in the beginning, and this like the graph one.
Okay, I'm again going back. Yeah. Yes.
Yeah, can you go down? Can you go down a little bit? Yeah, determining the height of the block from the ground. How is it? How will it be? Yeah, I have doubt in this. How will it be half times 0.9 times 6.86 minus half 0. Why will it be like that?
You have yourself done and you are asking me.
No, yes. So my question, I understood, like I have to use this one, like a half times 0.9 times 6.86 minus half times 0.2 times 1.96. I understood that. But then if you look at the graph, the ball is going upwards and then going down. So if you try to calculate this, you will be finding the maximum height by this equation that I have written on the right hand side. Can you try solving the question on your own? Like, are you getting the same thing?
See here, okay.
This is at t equals 0. When the time is 0, the ball is released. It goes up, and then
Yeah,
it stops there and comes down. So
yeah.
when you find the area, like subtract the area, it goes down, and then yeah, you do that. You find the area, and then you'll find the maximum height, but and not the height from the time t equals 0.
So they are not asking the maximum height. They are asking the time when the string breaks. Okay.
Yeah, exactly.
Yeah.
When
So,
the string breaks.
I think it will be just area under this curve. Okay, half into 0.2 into 0.9. Okay, let me draw it. Let me solve it. Same you will get. Okay, let me try.
No, so if you do that, you'll get the maximum height, like even after it releases.
No, no, see here. See here. Okay. So see what is happening. Let me remove this. Okay. I'm drawing the figure. Okay. Okay, so suppose the ground is somewhere here. Okay, ground is somewhere. This is the ball. Okay, so here the string breaks. So the height of the ball from here, that is this h that they are asking in the question. So by the time the string breaks, what is happening? It has certain velocity. So what will happen? The ball will go up till all the kinetic energy gets converted into the gravitational potential energy. Then again the ball will fall down. Again it will come back to the same position, and then from here it will fall down. Okay. So the ball
Yeah,
is taking certain time. Okay, to go from here to here, some certain time, say t. Same time it will take to come again back to the same same position here. Okay, same time. So it's like time of ascent is equal to time of descent, and then some time to again say T1 to go from this position to this point. Let me mark this position 1, position 2, position 3. Okay. So from the graph, if you look here, at t equal to 0, it had a velocity. It's a velocity time graph. So area under velocity time graph gives us the displacement. So that just from the graph I can find it out. So see here at 0, it is 1.96 here somewhere. Okay. And then after 0.2 seconds, okay, after 0.2 seconds, what is happening? Velocity is becoming 0. So that means it is this position here. So from here to here, it is taking how much? 0.2 seconds. So this t is nothing but t is equal to 0.2 seconds. Okay. Same 0.2 seconds it will take to reach from here to this position. Okay. So
Oh,
this,
that's why we subtracted.
so this will be again some position here. Okay. Some position here. Okay. So it will be how much? It will be 0.4.
0.4.
0.4. Okay. So now we have here. Now the area between the velocity time graph, that will give us the this height h. So this will be the height that we have to find out. So this we can find it out. This we can find it out. So it is the, how we will find it out? You can find it out. This is what? It's a trapezium. Okay. It is a trapezium. So its area we can find it out. What is the area of a trapezium? Area of a trapezium is
There is trapezium is half
Okay,
a plus b times h.
sum of parallel sides into distance between them. Sum of parallel sides into
Parallel sides
between
times the distance.
distance
Yeah.
between them. So it will be half. Sum of parallel sides will be what? That will be, that is, so see here it is 1.96. So this position will also be
1.96.
It will be 1.96. And this is given to you here. This parallel side
6.86.
6.8. I am not taking minus sign because I have to
Yeah, addition.
finding out the magnitude. Okay, 6.86, and the distance between them, that is the height, that is 0.9
0.5.
minus 0.4, that is 0.05. Okay, this is
Yeah.
0.05. Okay, so 0.5, not 0.5, 0.5 seconds. Okay, multiplied by 0.5. So I think this will also give you the same answer. Let us calculate. So let's calculate it. So this is 1.96 plus 6.86, that is 8.82 multiplied by 0.5 divided by 2 is 2.2 meters. 2.2 meters is the height that I am getting.
Can you go then check the answer? I've written the answer, I think.
Let's check if it is.
Oh yeah, that must be the I don't correct the answer. Yeah, that's the right answer. The answer.
Yeah. Okay. This you have not what earlier you have done like
Yeah,
this.
I've not.
So that is 3.8
Yeah.
coming from this. Okay.
Yeah, that's wrong.
Okay. So we have to do like this. So you will get 2.2 meters. So that's the answer. All right.
Right, understood.
Is it okay, Lasha? Are you understanding? If you're not, I will can again repeat. Okay.
I get it. Yeah.
Okay. So you can expect such questions in the exam. You should not make the mistake. Okay. So the ball is going up, then again coming down. So for going up from here to here, it is taking 0.2 seconds. Then again coming down, it is taking 0.2 seconds. This is 0.4 seconds. Okay. So now it's a velocity time graph. So area under velocity time graph gives us the displacement, that is the height. Okay. So the time I will take it, that is 0.9 minus 0.4, that is 0.5. And then it is just the area of the trapezium, that is half into sum of parallel sides. Parallel sides is just the value of the velocity here. So 1.96, and this value is given 6.86 and multiplied by the distance between the parallel sides, that is the time 0.5. You solve it and you get the answer. Okay. So let us move to one more problem. One more paper. So here also he has some doubts. October, November 2019. You also solve in the home, Lasha. Okay, any doubts you ask, send me the picture. Okay. Here you have the doubt.
No, sir. The other.
This.
No, I got understood. I have marks like I've circled the thing. Circle the question number.
This one.
Yeah, this question go down. Oh, this is the one I asked you the other day. No, I know this. I know this. You solved it.
Okay.
If you want, you can explain live if you want.
This one, understood?
Yeah, understood my mistakes.
Let's open another paper. October, November 2018. This one.
Yeah, go down.
This one.
So
Or
can you
yeah.
go up for a second? I think I understood this problem. The problem with those questions is that I forget to add the weight at the end.
Hmm.
So I think I understood this, but then you can explain it again.
Question number 3, state Newton's second law of motion so that you can tell. Okay. That compressed force is directly proportional to the rate of change of velocity. Okay.
Momentum.
Sorry, rate of change of momentum. Okay. Now, there is some toy rocket is given to that contains water and compressed air is there. Okay. Water is pushed vertically downwards through a nozzle by compressed air. The rocket moves vertically upwards. So like you can do, you take a balloon, you fill the balloon. Okay. And then you release the end. So the balloon, the air will come out, but the balloon will go up. Okay. So you can do that.
Yeah.
The nozzle has a circular radius. Density of water is given. Assume water leaving the nozzle shape of the center of radius and has a constant speed relative to the rocket. So that the mass of the water leaving the nozzle in the first 0.2 seconds after rocket launch is kg. Okay. So mass of the water that is leaving you have to find out. So density is equal to mass by volume. Okay. So density is given to you. Density is given to you. Just you have to multiply it with the volume. Okay. So but then how will you find out the volume? Volume you can write it as area of cross section into the length. Okay. Because it has a circular cross section, radius is given. So pi r square you can do and you can find out the area. Okay. Area of cross section you can find it out. Okay. But then length, in order to find out the volume, you have to find the length of the air that has come down. Okay. The water that has gone. But the velocity is given to you. Okay. Constant velocity is given to you. So just you have to multiply this velocity with the time. Okay, 13 into 0.2, you will get the length. Okay, and then that 13 into 0.2, that is how much? That is 2.6 meter. So that will be the length. So that length you multiply it with the area of cross section, you will get the volume. So that volume you multiply with the density, you will get the mass. Okay, so you'll get something, say 0.46 kgs. Okay. Calculate the change in the momentum of the mass of the water due to the leaving the nozzle. Okay. So it has a constant velocity. Okay, constant velocity. So the momentum is given by what? Mass into the velocity. But here velocity is not changing.
Mass.
Okay. It is the other
Mass-
thing that
mass
is
transfer.
changing. Okay, this is called as a
Yeah.
variable mass system, a variable mass system. So this is another way where in the momentum can change. Okay, momentum can change. Okay. So in B1 they are asking. So initial mass was given to them? No. Change in momentum of the mass of water due to leaving the nozzle. Okay. Okay, so that is just the mass that is coming out multiplied by velocity, and then force is equal to what? That is rate of change of momentum. That is dp by dt. So that is dp, that is change in momentum, is 6 divided by the time, that is 0.2 seconds. So you are getting 30 newtons as the force. State and explain how Newton's third law applies the movement of the rocket by the water. Okay, so we have written water exerting force on the rocket is equal to the force exerted by rocket on the water and opposite in direction to each other. Okay. The container has a mass of
Is your
point.
voice cracking? I think your voice is cracking.
My voice is cracking.
When you were reading did you read the
The container has a mass of 0.4 kg. Okay. The initial mass of water before the rocket is launched is 0.7 kg. The mass of the compressed air in the rocket is negligible. Assume that the resistive force on the rocket due to motion is negligible. For the rocket at time 0.2 seconds after launch, show that the total mass is 0.64 kg. Okay. So just you have to subtract this 0.46, and it's a 0.7 container mass plus mass of the container mass is 0.4 kg plus mass of the water is 0.7 kg. But then after that 0.46 kg of mass water is releasing. Okay, so that will get subtracted. Okay, and then the acceleration you have to find out. So that is F equal to m by a. Cannot hear me? Can you hear me, Lasha? Hello? Can you hear me?
in chunks?
Okay. So calculate its
Where
acceleration.
you don't speak, and then there's points where you speak.
Okay. So F is equal to ma. So A is equal to F by m. So that is So what was the answer? Acceleration is equal to force upon the mass. Okay. So force is exerted, that is 30, okay, divided by 0.64. But 47 is the incorrect answer, na? 37 will come. Okay. F is equal to m into s, A is F by m. So same force 30 Newton will act, okay, and force divided by the mass. So same thing will come. Force is 30 divided by mass, that is
So I think I understand my mistake.
Hmm.
Equals MA minus MG, right? No, MA plus MG.
Okay, yes, mg, you will have to subtract it, okay, maybe, yeah, na? So this is the thrust force, okay, in the upward direction. Thrust force is in the upward direction, yeah? And weight we will take in the downward direction. Okay, so see here, for this I am solving. Okay, so see here what is happening. Suppose this is the rocket here somewhere. This is the rocket. This is the rocket. So it is experiencing some force 50 Newton in the upward direction. Sorry, F is equal to 30 Newton in the upward direction. Okay, and but then there is a weight also that is acting, that is m into g. So the mass left is how much? 0.64. Okay, kg. Say if I take g as 9.8, or so say 0.64 into 9.8, that is the weight, acting in the downward direction. 9.81. So this is how much? This is 0.64 into 9.81. So that is 6.27 newtons, or 6.3 Newton is acting in the downward direction. Okay. So the net force will be what? Net force will be this minus this force. Okay. So the net force will be 30 minus 6.3. And then that is this force you equate it with mass into acceleration to find out the acceleration. Mass is 0.64. Okay. Multiplied by the acceleration. So you will get now. Let's do it. 30 minus 6.3. So that is 23.7 newtons, and you divide that force by 0.64. You will get 37. You will get 37. It's an acceleration. So you'll get now the acceleration is 37 meters per second square. Okay. So now you will get the acceleration as 37 meters per second square. Are you getting this? Are all of you getting this? Is it okay, Lasha, Hardik?
Yeah, I got it.
Okay. So upward force is 30 Newton, but the weight is also acting. That is in the downward direction. So the weight we can find it out by m into g. M
So wait. So
Uh.
which forces are acting right now? The weight
weight
and
and, weight and this lift force is acting 30 Newton. Okay.
oh yeah.
Yes. Yes. So net force will be 30 minus 6.3. Okay. And that is equal to the mass into the acceleration from the second law. Mass of the rocket now is 0.64 kg multiplied by A. So A will be 30 minus 0.64, whatever you get divided by 0.64, you will get 37 meters per second square. Okay. So like this, we solve the question. Okay. Okay, so let us end the meeting now. I know we have some more doubts. Okay. So we may have some another session. I will remind you about that. Okay, your exam is on 19th. Tomorrow is 18th. So maybe on tomorrow also we can have some session if you want. Okay. So
So I have more doubts. I'll send it.
Laisha, you also solve. Okay.
Solve papers.
And send me your doubts. Okay, I will try to answer. Okay. All right. So that's it for today's class. Take care. Bye, all of you. Okay. Prepare well for your exam. Okay. I'm ending the meeting. Take care.